Hey there, my name is Ben Rodney from ASHRAE New York, and I want to welcome you to this episode of the ASHRAE New York Designer Series and the brand new ASHRAE New York YouTube channel. We'll be bringing you educational content, interviews, and chapter updates, and it'll be open to members and non-members alike, or anyone just interested in the HVAC industry or updates on our chapter. You can find us on LinkedIn, Instagram, and make sure to go to our website, ashraeny.org, where you can sign up for our newsletter, check up on chapter events, and hopefully even join us as a new member of the chapter. If you like what you see here, make sure to hit the subscribe button below this video and then hit the bell to get notifications on any future updates to the channel. If you have any comments, questions, or conversation about this video, just leave them in the comments section. Thank you and enjoy the episode.
Okay, good afternoon, everybody. It looks like we have a good number of people that have started to log in. So my name is Ben Rodney with ASHRAE New York chapter, and we wanted to welcome everybody to episode 2 of our designer series. We're really happy you can join us today. Last week was very successful. We had a great meeting on stack effect on Tuesday, net zero last week, and so we're really excited today to welcome our new friends from Kansas, from Henderson Engineers, Glynis, Thompson, and Jake Katzenberger to talk about fire smoke dampers in healthcare facilities. So we have a few items we wanted to walk through before the presentation starts. If you have any questions, at the end of the presentation, we're going to do a Q&A. So just make sure to type them into the questions bar on your control panel, and then we'll select some at the end and have them answered. To earn your PDH credits, so this presentation is worth 1 PDH, accredited with the Practicing Institute of Engineering. At the end of this presentation, when you log out, there will be a survey. You must fill out that survey. We'll get your PE number and the information that PI requires to keep on file. And then within the next couple days, we'll be sending you a follow-up email with a certificate, as well as a link to a SurveyMonkey, because we'd love to get your feedback on the presentation and anything else that you want to share with us. We're also going to be recording this presentation and presenting it on our website, not immediately, so have patience with us, but it will get up there. And if I understand there are some people from outside of New York State, so if there's any other issues you need to address in terms of documenting your PDH status, please be sure to check with your state level. So I'm going to throw it over to Jake to start our presentation. Oh, sorry. One thing I wanted to apologize that I forgot to mention. Our upcoming schedule for events. Next week, we have a designer series on energy modeling strategies, followed by a regular chapter meeting on electrification, smart buildings, fan fundamentals, and disaster preparedness coming up. So be sure to check out our website for these events, and we'll be excited to see you at those. So now I'll throw it over to Jake.
Okay, thank you, Glynis. Would you like to start us off?
Sure. Well, for starters, thank you for having us. We're pretty excited to go through one of Jake and I's favorite topics, fire and smoke dampers and healthcare occupancies. So I'm Glynis Thompson. I'm a fire protection engineer based out of Kansas City, but I work all over the country, including in New York. I have a great relationship with the guys up in White Plains. I work there a lot, and I was working on another NYC project earlier this week. I primarily do code consulting for high rises and healthcare and other challenging code applications, and I'm pretty excited to share this with you today.
Yeah, and I'm Jake Katzenberger, and so I'm a mechanical engineer with our healthcare practice at Henderson Engineers, and I've been working in design for hospitals and different healthcare applications for the last 10+ years. And so I'm going to speak to specific damper applications and then some coordination items and different options with dampers that during this presentation.
All right, so first we're going to go through some passive protection specifics. So we're going to look at different fire rated assemblies, where we're going to be seeing those required in different kinds of buildings, and then we'll look through the specific damper applications required at each of those locations. And then we'll look through some miscellaneous items for damper coordination that you might run into during design. So let's get started with passive protection. So passive protection in general is going to be the rated construction that we see throughout buildings, and we're going to look at it really generally, and then we'll get more specific into each assembly. So in general, why is it required? So ultimately, our goal is to keep the fire wherever it started so it doesn't spread throughout the building. This allows occupants to egress safely and quickly, limits property loss, and ultimately protects the contents of the building, the contents of adjacent buildings if you have exterior rated walls, and then also protecting emergency responders to ensure that the building stays sturdy and standing while they're trying to do their job. So for this presentation, we're going to be looking at the requirements of IBC and also NFPA 101, as many healthcare occupancies are CMS deemed for Medicare and Medicaid, which requires compliance with the 2012 version of NFPA 101. So for this presentation, we're going to be referencing some requirements of both. So just keep an eye on that when you're looking at how this might apply to whatever building you're working on. But most of these requirements will apply to both healthcare and non-healthcare occupancies. So really, what is passive protection? So if we think about fire protection in general, we think about active systems that react to a fire, like alarms and sprinklers. But the passive protection is equally important, and it's all of the things that don't necessarily directly react, but that maintain sturdiness and separation with rated walls and ceilings, structure, and then all of the openings that are being protected in those assemblies, like rated doors and dampers. So it's incredibly important that we understand the types of passive protection and how our systems can interact with them, and how we protect them, specifically with dampers. So we're going to go through each individual term on this list to understand the differences and where they apply. Some of these terms will only apply to NFPA 101 or IBC, most cases both, but especially in the healthcare world, when we're applying multiple codes at once, it's really important that we use really correct terminology and understand where the terms apply and where they're coming from. So we're going to go step by step from the most restrictive to the least restrictive in terms of rated construction. All right, so we're going to jump right in and get started with the firewall. So I think Jake and I would probably agree this is the most commonly misused term in life safety, and certainly in my code consulting career. I've seen many assemblies that are not truly a firewall be called a firewall, and I'm sure a lot of you have experienced this also. So firewall is technically a term that only exists in the IBC. It's not actually mentioned in NFPA. And the definition of a firewall is a wall that is going to be separating two completely different buildings that are attached to one another. So this wall is going to go from foundation up to the roof slab, completely straight up. It won't be on a single floor. It's going to chop through the whole building. Exactly. So we may use this to get more out of heightened area restrictions for buildings, to allow a larger footprint, or to separate construction types. It's important that we acknowledge that in most cases, the two things on the sides of the firewall are actually going to be different addresses. So by calling something that's not a firewall, we end up requiring a lot more architectural and mechanical systems coordinated through it. So it's pretty rare, unless you're separating a building, to see the term firewall. And for what it's worth, NFPA 101, if it is identifying a separation between buildings, it will use a 2-hour fire barrier rather than firewall.
So as far as dampers and firewalls, it's a lot simpler. If a true firewall is much simpler than other other walls and assemblies because there aren't that many exceptions. Basically, you need a fire damper when you penetrate a firewall. No ifs, ands, or buts. There are a few caveats. If a firewall is also serving as a horizontal exit, you would need a smoke damper and a fire damper, so you'd have a fire smoke damper in the assembly. But to echo what Glynis was saying, verbiage is really important, and coordination between the code consultant and the design team is really important to make sure the correct terminology is used and we understand what the terminology is actually referring to from a code standpoint, so we don't misapply our codes and add dampers and over design a space for an owner. An important thing to look at, if you see a rated wall that's surrounding just one individual room, it's not a firewall. And so unless it cuts through the entire building, it's most likely some verbiage that needs to be coordinated with the design team to make sure that everybody's on the same page.
So jumping on to the next slightly lesser of the hardiness scale on rated assemblies. So we went from firewall and now we're going to look at fire barriers. And this is probably one of the most common ones that you'll see on life safety plans that we need to coordinate around. So a fire barrier goes from the floor up to the slab above. So a fire barrier is permitted to only be one story. It needs to go all the way up to the slab and can't stop at a ceiling. And this is most common because we're going to see it to separate occupancies in the same building around shaft enclosures, exit enclosures, like stairways that are enclosed, hazardous areas like a specific room that's rated because of its hazardous contents, and separating fire areas. So this is a great graphic. It shows basically that it goes from the floor up to the floor or roof deck above. And it pops up through the ceiling. So if you're in the field and you're trying to determine whether a wall is a fire barrier or something lesser, it's usually a pretty good idea if you can to pop up above the ceiling and see if it keeps going.
So fire barriers, I think, are the most difficult to decide how to attack from a mechanical perspective. Number one, depending on what the application of that particular fire barrier is, your application of dampers will be different. For instance, as Glynis said, these could be a shaft. Well, if you have a shaft, the building codes say you need a fire smoke damper with some exceptions on a shaft. And we'll talk more about shafts later, so I'm not going to go a lot of detail on that right now. If it's an exit passageway or a stair, you really can't penetrate that at all, even with a fire damper, because a stairway can only be served from a system that's dedicated to that stairway, and same with an exit passageway. So if you see it in that application, you got to make sure you keep all your other systems out of that assembly. And similar to the firewall, if it's a horizontal exit, it needs a smoke damper as well. So just looking at the plan and seeing a fire barrier 1 hour, 2 hour, it needs to still have some discussion as to what the purpose of that fire barrier is for a complete, so you can have a complete understanding of how to handle it. Now, as far as general fire barriers surrounding individual rooms, there are still some differences in code and quite a few exceptions that can be confusing, and there are differences in interpretation that we found as we've done work around the country. Number one, NFPA does not require any dampers in a 1 hour or less fire barrier, and with no caveats or suggestions. So that's the biggest difference between the NFPA and the IBC from this standpoint. The IBC has several exceptions, and the exceptions range from having a UL listed assembly, which is the same with all these different wall types we're going to talk about, or if it's a part of an approved smoke control system. That's an exception that's pretty common throughout all these walls, so we're not going to go into that in detail as well. The biggest one for fire barriers is exception 3 in the code, where it discusses that a wall penetrated by a fully ducted HVAC system, and the wall is 1 hour or less, you have fully sprinkled system, and it's constructed of 26 gauge steel that's continuous from the air handler to the air inlet or outlet, that fire dampers can be omitted in those 1 hour or less fire barriers. What we found, the typical interpretation of this is if you're fully ducted with that 26 gauge, and then you have a short run of flex duct to your diffuser, which is very common on supply systems, a lot of areas, that still accounts qualifies for this exception, so you don't have to have fire dampers. But we've ran across other code officials who have interpreted in a way that if you have flex duct anywhere in the system, this exception does not apply to that system, and so they require fire dampers at every single fire barrier. It can be really confusing, and there's no way of knowing without talking to a code official. So it's important to have communication, especially on this subject if you're working with a code official that you're not familiar with or a new jurisdiction, just to discuss how they interpret this. One helpful piece of information is that in the 2018 IMC code commentary, they address this issue, and they state that if a duct goes through a 1 hour fire barrier and then has a flex that's just between that ductwork and the diffuser, that's no more dangerous and presents no more risk to occupants than if you had a grill that ended right at the wall with no flex. So based on that commentary, they lean towards the stance that a short piece of flex duct in the system does not make this exception invalidated. But even with that, if there's some code officials that are under older codes that say, I don't care what a different code commentary says. So again, it's an important thing to understand and understand how your authority and jurisdiction is going to respond to this before it gets into construction and becomes an issue when it's much tougher to accommodate.
All right, so again, moving another step towards the less hardy of the requirements, we run into fire partitions. So this is a term that is only defined in the IBC. NFPA exclusively uses the term fire barrier, and they don't use the term fire partition. In the IBC, it's described as a wall restricting the spread of fire, openings protected, but it can terminate at a ceiling, which is different than a fire barrier. It can also travel horizontally, so you could run it up and over on an L shape to act as a rated ceiling. And we'll see this code term used in rated elevator lobbies, separating mall tenant spaces, sleeping rooms and hotels and apartments and whatnot, and rated corridors. So here are some great examples. Depending on what elevator or lobby requirements you fall under, sometimes you'll see a fire partition. The walls specifically separating the tenant spaces you can see there, and then the walls in between residential dwelling units in addition to the rated corridors. So fairly common.
Yeah, and so damper requirements for a fire partition are very similar to a fire barrier, except there's a little bit more leeway and more exceptions that apply. The same exception verbiage for the fully ducted system is still involved in the code in this one, but they have other exceptions that if you're in a corridor wall in a 1 hour that has a sprinkled system, you don't have to have any dampers. So a lot of buildings that maybe previously weren't sprinkled, but then they became fully sprinkled, you may have some differences where you'll have fire dampers in a corridor, but in a newer expansion where they sprinkled, there won't be fire dampers in those corridor walls. So that's something where in some older buildings, there can be a little bit of confusion where you have dampers in one area, but not another. But it's important to understand the codes that are in play when a project's being designed and not just match what was there before, assuming that that was correct. Obviously, there's other leeway for tenant walls where they aren't required to be fire rated for any other reason. They don't require dampers in those situations. And then some small duct work. Again, like we said, the provisions regarding the fully ducted system, the same considerations need to be made in code calls made to identify how the HJ is going to interpret those exceptions to make sure that they're okay and that they don't have some stricter interpretation than what would be common.
All right, so we've moved on past the terminology that includes fire, and now we're on to smoke barriers. So you are likely familiar with smoke barrier requirements and smoke barriers on plans if you work in a lot of healthcare occupancies or healthcare facilities like an ambulatory healthcare occupancy, but it's less common in other occupancies. Technically, a smoke barrier can be a wall or a floor or a ceiling, and the key term is that it's constructed to restrict the movement of smoke. We typically see these in occupancies where occupants cannot egress readily on their own. So think healthcare occupancies or prisons, where we are going to employ strategies to egress people horizontally throughout the building, so moving them from compartment to compartment. We see these to separate smoke compartments in healthcare occupancy, and also there's some requirements regarding atriums being separated with smoke barriers as well. So this is a great example of a plan. This is a healthcare occupancy, so we're looking at the 5th floor, and you can see 5I and 5J. That's 2 separate smoke compartments on this wing of this hospital. So we have a smoke barrier that carries a 1-hour fire resistive construction, which is kind of catches people up, I think, a little bit. But it's going to be separating these 2 smoke compartments. So if there's a fire on one side, they can move hospital patients to the other side of the smoke barrier to shelter in place, to give more time for potential evacuation of the building, or whatever the egress strategy is for that floor of the hospital.
Yeah, so smoke barriers in general, a smoke damper is required when you penetrate a smoke barrier, but there are exceptions. One thing I want to say about that, though, is as Glynis mentioned, it's required to have a 1-hour fire resistive construction, but that doesn't mean it needs to be a fire smoke damper. That is a common misconception on those, and you don't necessarily have to put a fire smoke damper just because it is a smoke barrier and it's required to be done that way. And so that's another thing. Sometimes you'll see on there someone has on a code plan 1-hour fire smoke barrier just because it's required to have that construction type, and that can throw you off. And that's another thing to clarify, because there is a place you would have a fire smoke barrier where it needs to have a fire resistance and a smoke resistance, but it's different from something that's separating 2 smoke compartments. So it's important to clarify if you see that on a plan and it looks like it's a true smoke barrier as Glynis described, but it has other verbiage on it. So the exceptions where you don't have to put a smoke damper, there aren't tons of them in this one, but the main thing is if you are only have air outlets or inlets on one side of the smoke barrier, you can omit smoke dampers. So the places where we see that most often is if you have an air handler serving a suite or some rooms on a different side of the smoke barrier than the air handler is, and it just runs from, say, the mechanical room straight over to through the smoke barrier to serve an area. You can omit that smoke damper in that place. It's a little bit different than fire, because fire, even if you run through a fire rated wall, a fire barrier, and you run through it and you had no openings, you still have to have the damper. There's no exception in that, because fire can collapse the duct and there needs to be protection. But smoke is different, where if you don't have openings, you're running through a smoke barrier, or you have a duct, say for coordination issues, you have a duct on one side and it runs through that smoke barrier and then comes back through with no openings just to kind of avoid an obstacle. Well, if it just goes through and comes back, no openings, you can avoid a smoke damper at each of those penetrations as well. Obviously, smoke dampers are a lot more cost. They're a lot more difficult in the testing. So we want to avoid smoke dampers as much as we can. That's why it's important early on in a design project to understand where these smoke barriers are and try to think that through as you're laying out ductwork, laying out systems, to minimize the number of penetrations to make it easier for the owner in the long term of the project. Another exception was new in the 2015 IMC. It's saying smoke dampers aren't required in I2 Condition 2 systems that are fully ducted, fully sprinkled with quick response sprinkler heads. So I2 Condition 2, that's mostly like behavioral health. Condition 2 refers to places where people have free movement, yet but egress out is locked. So that would be behavioral health type situation. So you can look at that if you're under the 2015 or greater, and in one of those projects, is something to look into to see if that additional exception could be taken advantage of. Another thing is in the IMC, it refers to this section as corridor smoke barriers. And one important thing to note on that is the corridors referred to in there are egress corridors that are required to be fire rated by the code. So just because you have something that's labeled as a corridor on the plan doesn't mean you need smoke dampers every time you serve it. And that's a common misconception that, again, I think the 2015 IMC, they have a section that kind of clarifies that to make it a little bit easier. But in past years, I think there's been some confusion. And so there are some facilities out there that probably have some smoke dampers where they don't really need to. So again, if you're going into an existing facility, don't necessarily have to copy what they did, making sure that you are designing around the current codes when you're under during the project to make sure we minimize the number of dampers that the owner has to maintain and test.
All right, so we are almost at the end of our list of the least hardy of these rated constructions. So a smoke partition. I'll note right off the bat that a smoke partition in IBC is a term that's typically used for healthcare occupancies, and NFPA 101 calls for smoke resistant construction in corridors. And the key point for smoke partitions, it's a non-rated assembly, so that means there's no fire rating associated with it. It can terminate at a ceiling that is constructed to limit the transfer of smoke. So in most cases, you'll see this, and it won't be a rated assembly for the ceiling, but the smoke partition is permitted to terminate at that ceiling. So it'll go from the floor to the ceiling or the deck above, depending on how the ceiling is constructed. We'll see this most commonly in healthcare, and here are perfect examples for the corridors. So on the left side there, you'll see corridor walls in new healthcare or existing healthcare that are sprinklered. So if we have a sprinklered building, we are permitted to just provide these smoke partitions or smoke resistive construction in the corridor, non-rated. And on the right side, you'll see corridor walls in existing non-sprinklered healthcare. Non-sprinklered healthcare gives me jitters a little bit, but there are still some out there that are non-sprinklered. And when we run into that, we're required to have half-hour fire resistance rated corridors.
So smoke partitions, the biggest thing with smoke partitions is dampers are only needed for air transfer openings. So in a smoke barrier, whether you have a fully ducted supplier return or not, the smoke dampers are required, barring the exceptions that we mentioned before. But for a smoke partition, even there are no exceptions needed for a ducted system. So if you're penetrating a corridor with a smoke resistive in a ducted system, like into a patient room, you don't have to have dampers at each of those penetrations. But if you're in some facility where you happen to have plenum return for whatever reason, and you had a smoke partition and you had transfer openings, you would need a smoke damper at those transfer openings. And we'll talk here a little bit later about incidental use spaces. And those are constructed as smoke partitions and possibly a fire barrier. So those are an area where they may be in a part of a building that you would have plenum return, where you need to look at transfer openings and whether or not a smoke damper would be needed at that point. So one of the toughest things in a new building is deciding, do you need a shaft when you run ductwork, through floors? It can be confusing, and part of it is because the code has multiple different areas that you have to go to make that decision. So I just wanted to kind of put in here a couple of the questions that I like to ask when I'm looking at a new building, deciding, do we need a legitimate shaft, or can we route this just maybe in a chase to conceal it, but not a true code shaft? So the first thing that you want to ask yourself is, what's the occupancy of the building? So the way that the code is written is, it says in all occupancies other than group I2 and I3, and then it goes on to describe what's needed to avoid a shaft. So if you're in I2 or I3, even if you're just going between two floors, you need a legitimate shaft at all times based on the way that code is written. The other question is, are the floors rated? Because there's two different sections you go to. whether your floor is a rated floor or it's not. And then how many floors does that duct system pass through? So the first thing we're going to talk about is a penetration horizontal assemblies for a fire rated floor. So the code says that if a duct penetrates 2 floors or less with fire rated floors, you don't have to have a shaft if you have a fire damper at each floor. Obviously, if you can always add a shaft, and that meets code if you don't want to have fire dampers, because to be honest with you, fire dampers in a floor are very difficult to access depending on where they're at, and pretty difficult to install just because of the clearances and during construction, the clearances in that concrete, depending on the floor type, can be difficult to get that damper in and get it installed and the coordination. But if you have a fire rated floor and you're only going between 2 floors, you can definitely do it without a true shaft if you have fire dampers at each floor. The next one is in section 717.6.3, where it talks about in a building that does not have fire rated floors. Now, this doesn't really apply to healthcare, but because we're talking about shaft enclosures, I wanted to include the entire picture. Most healthcare applications would have fire rated floors. But this is just good general information that kind of encases this entire discussion. So the way the section talks is if you have a duct that goes between 2 floors or less, if the floors are not fire rated, but the floors are made of non-combustible materials, you can get away with no shaft and no fire dampers at the floor, assuming you seal around, do good fire caulking and seal around the openings. And this diagram here is from the code commentary that describes what they're discussing with connecting 2 floors and the fire caulking. Now, if you go between 3 floors, so I have a little bit taller building, you still don't have to have a shaft if you have non-rated floors, but you need to make sure that you have, again, you go back to the fire damper at each floor in order to avoid that shaft. And again, throwing fire dampers, it's really easy to do on a plan, but in installation, fire dampers and floors are pretty tough. So really think that through and how that assembly is going to work before you jump to that option. And again, you can always have a fire rated shaft, and that will meet the intent of the code as well. So when you have a shaft, what does that do to your ductwork? So anytime you have a shaft, you need a fire smoke damper per the IBC. And there are some exceptions for that. And we're not going to talk about all the exceptions. A lot of them are the standard ones we've already kind of discussed with UL enclosures and assemblies and stuff like that. But in general, you're supposed to have a fire smoke damper, and there's some exceptions where you can just bring it down to a fire damper. But the one exception I wanted to discuss is the exception that allows for steel subducts. So if you have a system that, for instance, stacked restrooms, stacked dryer vents, there's a few times where you would not want to put a fire smoke damper in each penetration into a shaft. So there are allowances in this section of code to talk about what you can do to avoid fire smoke dampers when you go into a shaft. And what that includes is a couple of different things. First of all, the opening would have to go into the shaft and have a 22-inch steel subduct. So the way that works, the subduct in theory is it's going to prevent if fire does get through that on that one floor, it'll prevent it passing into the shaft and to other areas. And so that subduct could go into the shaft, and that shaft is open, and that shaft carries the airstream. Or if you had a duct in the shaft, that subduct could go into that other duct and extend vertically 22 inches. The other portion of that is that the shaft needs to have a exhaust in the shaft that provides the code says a continuous upward airflow in the shaft itself. So you're going to have a fan at the top of the shaft, and it requires it to be above all other connections. So it cannot be like at the top level and then have another connection above it. It has to literally be above all the connections. And it says continuous upward flow. So that term continuous kind of leads to the discussion of, does that mean that that fan has to be on emergency power if you're using this exception? And that's something that you need to think through on each project and with your AHJ to make sure that that interpretation is correct, because we don't have a fire smoke damper, so that subduct, it helps protect against the fire, and that continuous upward airflow helps protect against smoke, because if you have continuous airflow, that shaft is going to be negative compared to all the other spaces, so that's going to be the smoke protection to keep the smoke from traveling between floor to floor. So it's important not to just take this for granted, throw a fan up there, and say we're good without thinking about that continuous portion of the code language. The other thing to think about is how are you going to control that fan if your exhaust on all these floors is constant. It's pretty easy. You can do a constant volume fan, but there's a lot of applications. We talk about dryers in here where those are not a constant airflow. And so you have to keep that continuous upward airflow no matter what. So there's more complex control systems that we're not going to get into here that need to be thought through when you're using this exception. Again, there's a lot of applications where this can be used and where this is a very valuable usage, but it's not for every application. And there's some things that need to be thought through before implementing it on a project.
All right, so let's talk incidental use areas. So the table here is a table in the 2018, it's table 509 in the IBC. I didn't have it on the slide, so I just want to point out I did just open the book to find the table number. And this is a really important table that we run into for incidental use areas that might be considered hazardous when we're working on a project. What's really important to note about this table that I think is frequently missed right off the bat at the beginning is many of the requirements in the separation and/or protection column call out providing either a 1 hour fire rating or an automatic sprinkler system. And in most cases, especially if we're looking at healthcare occupancies, the building is likely already provided with an automatic sprinkler system. But that doesn't necessarily mean that we don't have to provide anything. There's a footnote to this table that clarifies that if you opt for the automatic sprinkler system option on this table, that then you need to provide a smoke partition around that room and protect it as necessary depending on the application. And there's a lot of items in this table that are specific to healthcare occupancy. So in the IBC, I-2, institutional 2 is what's considered healthcare. So we can see there's specific requirements for laboratories in healthcare, laundry rooms, etc. And this table helps identify a lot of the times when hazardous rooms need to be protected in some way. So just remember that if we are sprinklered, you do not have to provide the 1 hour fire rating if it says 1 hour or, but with the sprinkler system, we need to still protect the room with a smoke partition and then protect it accordingly on our mechanical drawings.
Yeah, and another thought on that table has changed over the last 10 years. And so there's a lot of designs and a lot of designers who are still implementing just out of habit criteria that was in an older code that's no longer required now. So some things on mechanical rooms or even some storage rooms where people are used to rating every single storage room, that's not necessarily required anymore. So again,
correct.
Another thing to let's look at that for the code that you're designing under and not just use old habits and create ratings where we really don't need to have ratings and where we don't really need to have dampers. Again, these rooms may not be rated, but in a healthcare occupancy, your soil storage and clean utility, those will be 1 hour rated based on this incidental use space. And so it would be 1 hour fire barrier. So however those exceptions work, you may or may not need a fire damper when you penetrate those. And again, it's a smoke resist, or it restricts the passage of smoke. It's a smoke partition. So you may need, if you have a transfer air, you may need a smoke damper. So if you do have a return air plenum and have one of these spaces, it's important to kind of look into that and try to avoid, if you can avoid having a true transfer air duct, that's probably best if it's a really small room. But something that you have to think about, and that smoke damper portion is missed quite a bit, and something that isn't really obvious in the way the code's written. And it would be nice if it was changed to make that a little bit more obvious. So we're going to go on to some specific damper requirements and talk more about specifics of the dampers. Now that we've talked about where they are applied in the building, what are these dampers and what are some things you have to think about? First of all, fire dampers. We're not going to spend quite a bit of time on fire dampers. Most of our rest of our discussion is going to be smoke dampers and fire smoke dampers. But obviously, the fire damper works. There's a spring-loaded either curtain or spring-loaded blades that have a fusible link, and it melts when temperature gets too high, and that's how it closes. Very, very simple. The only thing is you have to coordinate the fusible length with the temperature of the air. But fortunately, unless you're in industrial applications, I mean, it's going to be pretty consistent most of the time. Not something that we have to think about on a project-to-project basis. And again, coordinating what damper is installed with the rating of the wall assembly. That's something that usually is kind of an automatic thing, but want to make sure that things are not misapplied or dampers that are rated for a lower rating are installed in the wrong wall. Another thing back on the fire dampers, so there are different types of blades. So you have the curtain type. You have the curtain type where the blade is out of the airstream, which makes the total location the damper has to be a little bit longer. And when you're going in floors, that's something to think about because it's going to be bigger than your actual duct, but it reduces the static pressure loss. And there's also the blade type that some owners like because those are actually easier to test and reset. But again, they have those blades in the airstream. So on high velocity systems, they may increase the pressure drop of your system. So when you're doing your specifications, something to think about to just make the best choices based on the needs of a specific project. So smoke dampers, there's a lot of different ratings. The code allows class 1 or class 2. And we're going to talk more about this stuff later just down here. So I'm not going to spend a lot of time on this slide. But it needs obviously a smoke detector. There's multiple options on how that can be applied to close the damper upon detection of smoke. And it needs to be coordinated with your HVAC system as well. So each different damper type has a specific UL listing. And the important thing on this slide is not to memorize every single UL listing on here, but to understand that these UL listings are different depending on the type of damper. And the damper cannot be installed in a way that's different from its UL listed assembly. You can have no deviations. These are tested as a full assembly based on the details that are provided from the manufacturer, and deviations will violate that UL listing. Another thing is you see, for instance, UL listing is different for ceiling radiation dampers as fire dampers. So you can't just apply a fire damper in a ceiling radiation damper application. And that's another good reason to use proper terminology on a project. You don't want to say, hey, put a fire damper at this grill, when what you really need by code is a ceiling radiation damper. Most of the time, everybody knows what is intended and it gets installed okay, but that's just something to prevent possible miscommunication or issues in the field, to use proper terminology when you're applying these dampers. So we're going to talk about coordination items, and really mostly regarding smoke dampers, because those require the most coordination and have the most options. So first of all, the IBC requires that a damper needs to be a smoke damper has to be shut down when an AHU is turned off if the smoke detectors require a certain velocity to work. So on the next slide, we'll show a couple different smoke detectors, but there are certain smoke detectors that are the probe type that if you have no velocity across them, they're not going to be able to detect smoke. And there's others that are kind of more spot type that can work with no velocity. It's important that if you don't have a fire alarm system or building automation system that can coordinate the shutdown of that damper with the unit, you need to make sure you have a smoke detector specified that requires no minimum velocity. Again, the fire alarm system is the best to do that coordination if you have one. Building automation system is second best. And then if you have neither, it's important to look at options, but I would say the no flow smoke detector would be the best one. Another important thing with your AHU is to have a high or low static duct static sensor at your unit, because if smoke detectors that close off the majority of that airflow close, you could blow out a piece of ductwork And now with most DDC systems, those are pretty reliable, pretty fast way of preventing damage to your unit or your ductwork that it's not like a blast door that will be open and no one will know and be leaking air into the plenum for years to come. All right, so here are the different types of duct detection. So duct detection, there's no one way to do it. The code talks about different areas. The most common is to have the smoke detector at the damper within 5 feet of the smoke damper. And so that's going to be the most common that we'll see. But there's options that if you have a full smoke detection system, you can use that to close your dampers. I mean, a lot of facilities don't because that's really expensive. And there's others, if you're going across a corridor door, there's options in there. So there's options if you're trying to minimize cost and already have detectors everywhere else in the building, things you can do. But for the most part, they need to be within 5 feet of that smoke damper to operate. And again, one size doesn't fit all. Coordinate the smoke detector type that you install with your other system needs to make sure everything is coordinated and operates properly. And then who is providing the smoke detector? If you have a fire alarm system on the project, typically you want them to provide the smoke detector just because it needs to coordinate with their system and communicate with their system. If you're in a building that has no fire alarm system, then obviously it would be provided with the smoke damper, which would then be easier to coordinate because it's going to be tied in with that. So it's not a one size fits all how these work, and you need to coordinate with the rest of the design team and the building owner when specifying these detectors. And then again, smoke dampers have quite a few different options, and I'm going to run through these just really quickly. The first of all is the blade type. So there's the grooved and airfoil blades, and the big difference is these the groove type blades, they're a lot cheaper. So if you don't say one way or the other, they're the ones that a contractor is going to purchase. The airfoil blades are pretty significantly reduced pressure drop. So in any medium pressure system or even big return air systems that have a lot of smoke dampers in them, I would definitely recommend the airfoil blade because that pressure drop can add up over a number of dampers and create issues with your system. So make sure you specify the proper blade type that you want in your specs. I mean, at minimum, I would say, airfoil blades in every medium pressure system, and low pressure, I mean, if cost is not a driving factor, I would probably go ahead and recommend that as well. But you can get the pressure drop data for all these to make that decision for yourself. There's a couple other options as well as far as resettable temperature links that can reset through the BAS or through the fire alarm system. There's temperature link override. So if you have a smoke control system, you can provide that, and so that they can override that damper if it gets activated for some other sense. And then there's open close indicators if you have a fire command panel, so it can communicate back the position of each of those dampers. These are things that you want to make sure you don't specify if they're not really needed for the project, because that's just cost to the owner that they don't need to spend. So make sure that you think through in your specifications where these are needed and that you identify which dampers need those options. And obviously these dampers need to be tested, and there's multiple options for manufacturers to test switches, and also through your fire alarm contractor. So if you have a fire alarm contractor, talk to them to see their preferred test, whether they're providing the test switches or they need provided with the damper, and then coordinate with the owner the location of those. Some owners like those in the ceiling, so they don't have to get above the ceiling to test it. I mean, others want it in an accessible location. So that's another coordination thing with these to make sure that the entire design team is on the same page. So there's also a couple different options for the actuator. So number one, the actuator needs to be coordinated with the voltage. Typically, in my experience, we've always done 120 volt unless the owner wants a lower 24 volt, or pneumatic actuators. I've had some owners who prefer a 24 volt so that their own maintenance people can go and do maintenance. They don't have to have a certified electrician to come there to do maintenance on those actuators. So that's a good reason to do that. But again, that the voltage and then needs to be coordinated, and the transformer needs to be coordinated in the field as well. There's a couple of different locations for actuators. So actuators need to be accessed for maintenance. And we need to make sure that that maintenance access is maintained. And it really takes like 6 inches or so on the side, because you'll see a shaft and then you have to be able to pull that actuator off the shaft. So a lot of healthcare, you'll have ducts stacked against walls. And so that can sometimes be overlooked. And it's an issue then when the owner is going to try to have to do maintenance on that actuator. There's a lot of different options. So you can have an actuator in the airstream if you're in a tight spot. So it makes it so you just through the access panel, you get to that actuator. The only problem is that's additional pressure drop on your system. So that's an energy issue. That's also, I mean, just through the lifetime, having that in the airstream, just creating a pressure drop is something that you don't want to do unless you absolutely have to. And those actuators can be installed on a lot of different places in different areas. It's just making sure you coordinate if it has to be installed on the bottom or the left or right, that you coordinate that to make sure it gets installed on that proper side. And then in general with these is coordination for access. These have to be accessed again very regularly, especially in healthcare environments. So in every fire damper or fire smoke damper, there's going to have to be an access door. And that access door needs to be accessible. It needs to be the proper size, at least 10 by 10. And so then if a duct is smaller than 10 by 10, it needs to have a removable section of the duct, you know, like if you have like a 6 or 8 inch round going through a wall with a fire damper. And then it needs to be coordinated in the field that you don't have anything else running underneath those. So even though if you on your mechanical drawings have these located in the access doors in the most accessible location, and then conduit gets run underneath them and they're not accessible, well, that's going to be a problem for the project and for the, I mean, it could be 50-year life of that damper and someone have to go up there and trying to access that. So it's important to be really protective of these access spots. And there's a number of different ways in which you can do that. I mean, nowadays that most projects are doing full coordination drawings. That really helps because those issues can be found before they're actually in the field and things can be offset. It's also important in these just to coordinate in your own drawings, making sure that there aren't big banks of piping or conduit shown on all your own construction drawings blocking access to these dampers. The other thing is location above the ceiling. Someone has to get up there to fix that, to test that on a regular basis. So make sure if it's 4 feet above the ceiling, make sure there's a proper sized access panel or a removable ceiling where they can actually get up there to physically get a hand up there to test and to do maintenance as needed. There's also a lot of, we've had several clients who've gone through and asked us to review their code plan and review their building to make sure, see if there's any dampers that are no longer needed by the current codes. And then they decommission those just because over years, dampers get applied in a way that's above and beyond what the code requires under either just good intentions and misunderstanding the code or a code official who didn't quite understand what they were enforcing. And so it's been worth it for them, the amount of time and money they spend testing these on a regular basis to decommission dampers that are not required by code and that were put in for whatever reason. Because even if it's in an area that's not required, they still have to test it the same testing, even if they say, well, this isn't. So they have to fully go decommission it so it can't operate anymore, and then put a label on it to say that it's no longer under commission. That's pretty much the extent of what we have. So another thing the last thing I want to talk about is fire stopping. So there's a lot of options, and over the last 5+ years, there's been options that have for increased space, instead of having retaining angle on both sides, options for one side retaining angle, or allowing fire stopping around the perimeter on one or both sides to minimize the installation cost, but also make it so it's easier to install in certain tight scenarios. So it's important the codes don't quite refer to this, and that's why it's important to look at the UL listing and make sure if you're going to do something that is different, that you apply it specifically how the UL listing requires. So that's all we have for today. I appreciate you guys' attention. If there's any questions, we'd be happy to entertain them.
Yeah, that was great. We actually have quite a few questions from our attendees, so I'll just go through a few of them. The first one is, can you just briefly describe, so some dampers have fusible links only, some have actuators only, and some have both. Can you just briefly describe which have one or the other or both?
Yeah, so a fire damper will have a fusible link, one that's fire only, not fire smoke. A fire smoke, it will have an actuator because the actuator needs to open and close the damper with the detection of the smoke, detection of smoke. And so it also has, like I showed in one of those previous slides, it's not a true fusible link, it's a resettable fusible link in the fire smoke dampers, and so that's what detects a higher temperature and closes it for fire. So it's fire smokes that have both. Fire dampers, in my understanding, I did some research just last year trying to find a fire damper that could be overridden, and they didn't have one that I found. And so you had to do a fire smoke if you had a fire damper that you needed to override for a smoke control system.
Okay, great. The next question is, how do you know what fire rating of the damper should be? So I think there's always some confusion between 1 hour walls and 1.5 hour rated doors and various things, but is the rating of the damper the full rating of the wall, or half the rating, or something else?
Yeah, let me go back to this slide here. And so this shows the rating of the wall and the damper rating required per code.
Sorry,
so you can see if it's less than 3 hours. Oh, sorry.
We can't see your screen, Jake.
Yeah, that was
sorry. Let me just speak to that then. So I'll just say, yeah, in one of our previous slides, we showed, I can present real fast. So this slide, it shows that, if it's a less than 3 hours rated assembly, your damper has to be at least 1 hour. If it's 3 hours or greater, it's 3 hours, and corridor walls or assemblies are just 1 hour. So that corridor damper that we briefly spoke about, that's like that 1 hour assembly, but that's why they call it a corridor damper, because you wouldn't use that anywhere else. But I would say 95, 99% that we see are going to be 1.5 hour dampers, because we don't see many walls that are over a 3 hour rating.
There's a question for a fire smoke damper. Won't the smoke activate the damper first, thus making the fire sensor unneeded? So I guess that's a discussion between the fusible link versus the smoke damper itself.
So it depends, ultimately. It depends on the nature of the fire, and also if the smoke damper is acting as smoke being detected inside of that ductwork. But if the fire is, let's say, directly below, and if your duct is sealed up really well, it will experience heat from below closing that damper. So yeah, it's not always necessarily that situation, depending on where the fire is. But if we do have a fire that's immediately below a duct that's not necessarily open to a space that has smoke in it, if it's just passing through, as Jake mentioned, if it's serving a room elsewhere outside of the rated wall, that we do want to close off and protect the fire from spreading to the other side, even if smoke isn't being transferred through the duct. But great question.
And plus, yeah, and a fire damper, a fire smoke and just a smoke damper are not equal. If you download the two cut sheets, the materials are going to be different and the way it's constructed is different. A smoke damper can be installed, within a certain feet of the wall. It doesn't have to be right in the wall, but a fire smoke has to be installed in the wall with the breakaway connection. So if a fire breaks something down, it's still protecting. So yes, I would say logic is right that the smoke damper would probably trigger first, but that smoke damper is going to be knocked out of the wall. A fire damper will stay in the wall, and once those flames get going, still protect. So I think it has both in there, but it's really for after the fire goes that fire damper is much more robust in its installation and in that application.
And so I guess that's the biggest difference between protecting it against fire versus smoke migration and the way those two operate. Another question, only passive system is required by code, i.e. NFPA, IBC, IMC, etc. Or does code require active system for some cases? And what is an example of an active system versus a passive system and the code requirement?
Sure. So this gets into kind of the nitty gritty of fire protection engineering. I wish I could say that there wasn't 15 different types of active and passive systems, but they're really just generic terms. So we use passive system to describe things like rated wall, rated construction. An active system, an example of that would be an active fire sprinkler system, like an automatic system or an automatic fire alarm system, or a hood suppression system is an example of an active fire protection system. So usually, almost always, you know, there should be a fire protection engineer or someone else, you know, specifying the majority of the alarm and sprinkler stuff, but we might run in, mechanicals may run into things like hood suppression as an active system. But primarily, we just use passive to describe rated walls.
We do have a couple other questions, but it is 1 o'clock and we're gonna be respectful of everybody's time. So just if you have any other questions, just send them to ASHRAE, nyc@gmail.com, and we'll be happy to get those questions over to Glynis and Jake. And just a reminder, when you exit out of this, make sure to fill out the survey so you can get your PDH. And then when you get your certificate, there will also be another survey in that email. Please respond to that. And Jake, Glynis, we really appreciate you presenting your knowledge with us. And for everybody else, thanks for joining, and we'll see you next week in episode 3.
Thanks so much for having us. Have a great day, guys.